Venga, vamos a empezar la sesión, por favor. No, yo solo voy a presentar. Hola, por favor, vayan ocupando sus asientos. Hola, a ver, por favor, el sector de mi izquierda, que es vuestra derecha, está bastante lleno. El sector de mi derecha, que es vuestra izquierda, está bastante vacío. Por favor, distribúyanse para que el avión no se caiga. Ok, vamos a empezar. Os recuerdo la agenda de la tarde. Y me recuerdo a mí mismo. Ahora vamos a tener la última presentación como tal, una muy interesante. Después tendremos la asamblea de socios, asamblea extraordinaria, bueno, eso es un término técnico, pero vamos a asamblea. Los que no seáis socios todavía estáis a punto de serlo. Cuando acabemos os podéis apuntar por 5 euros el año natural. Solo son 2 meses, así que igual nos interesa, pero tampoco son muchos. 5 euros. A ver. Y luego, a partir de las 7, os recordamos que ahora pondremos las direcciones aquí, las actualizaremos, porque tenemos unas cervezas en un lugar que... El Café Salambó, pero luego lo pondremos. Y a esto es para todos los socios. Acordaos de llevar el lanyard para que no se nos cuede ningún borrachín. Solo los borrachines naturales del lugar. Y tendremos la cena a las 9 en la taberna del cura, que eso es para lo que se hayan apuntado. Si alguien quiere asistir y no se ha apuntado, que contacte con nosotros porque igual hay plazas libres. Entonces, ya iremos diciendo. ¿Vale? Entonces, sin más dilación, doy paso a la siguiente charla, que también va a ser en inglés, pero seguro que no hay ningún problema. Y es Pablo Lucente de Entity, que tiene un título, una mezcla de inglés-catalán muy curioso. BMP de Pa Am Tomaquet, Your BGP Monitoring was missing. Y no lo he dicho bien ni en inglés ni en catalán, pero bueno. Okay. El PDF. Control, ¿cuál era? ¿Eh?
Yeah, I prefer this. And
Ah, ya.
Okay. Hello. So this is Paolo Paolo Lucente from NTT, and let's speak some BGP and BGP monitoring. I did review my pronunciation of bread and tomato with Christian, Pam Tomaquette. Yes, good, passable. Okay. Anyway, so I am Paolo. I work for NTT for a division called GIN, Global IP Network. And essentially, it's the division doing IP transit, global IP transit for NTT. And specifically, what I do collect data collection and, big data and data analysis and things like that. Starting with NetFlow and then with NetFlow IPFix and then SNMP, and then after that, streaming telemetry and things like that. So essentially, I'm the guy that you give me the data and I make something useful out of it. And if you want to contact me and whatever, I mean, I am available on social media as well. Of course, different handle for every social media, not to make it very easy for you, okay? Fantastic. So why in 2023 we speak about BGP at an event? Because BGP is pretty much ubiquitous, right? So whatever you do, so it's very relevant for an event like this, but let's say you do internet, but let's say you are an enterprise network, you do layer 2, layer 3 VPNs, you do data center interconnection and things like that. You are probably running BGP. And for the ones that missed it, there is also who is playing Battleship with BGP communities. So it's really, you can use BGP for anything. So as the ancient wise man said once, I mean, since the time in which telecommunication was, smoke signals between towns, they said, if you run it, you better have a look at it, right? And why we want to have a look at BGP? Because for whoever knows BGP beyond just the code points and the message types and this and that and what the capabilities and that, that it has two qualities BGP. The one is that it scales great. In fact, we can run the whole internet over BGP, so it scales. But how it scales? It scales just by information hiding, right? So because of that, monitoring BGP, it's not a trivial task, right? So it's not just I do a BGP peering and now let's see what I get, right? So it has always been, the challenge to extract as much information from routers as possible, in order to get the information that we want, in order either to take decision or troubleshoot, debug, and things like that. So before BMP stands for BGP Monitoring Protocol. So if you wanted to check how people were advertising information to you, so ad ribbing, you had to use screen scraping. That was the most advanced format in which you could do that. If you wanted the lock rib, so what it's actually installed in the router, you could do a BGP peering with the router. And so if you have a root collector and things like that, I mean, you could manage that. And as well, if you want to check from a monitoring station, what you are advertising to the rest of the internet, for example, again, you have to do, screen scraping. There was nothing really advanced. So BMP, it was standardized in this RFC 7854. The first draft was, so in ITF, there is this process in which you start with a draft and then incrementally people, fight over details and things like that. Creative minds fight over details. So, there are iterations and iteration and iterations. So this protocol evolved, but it took quite some time to get from the initial proposal to really the RFC. If you see, it's from 2008 to 2016, it's 8 years. And you know that in the industry, I mean, a lot of things happen. For example, what happens is that between 2008 and 2016, you have non-relational databases, you have big data. So at some point, you know, it's very possible to store, to accumulate and absorb a lot of information in your, you know, data pipeline and your data lake and things like that. And so because of that, then, you know, there was an increased hunger for more information. So BMP at the very beginning, it was just like, okay, let's see what people are advertising me, and maybe I am filtering out these routes, and maybe it's because somebody is trying to do an hijack. And, you know, that was BMP, that's it. So you could do pre-policy edge ribbing. So just see, you know, what routes you are being advertised, and probably some of them, they were filtered out. And then you go there and you say to a guy, you are a bad guy because you are sending me some routes that I filtered. But then people, you know, wanted to have more insight and see as well, like, oh, how my policies are performing. So let's do pre-policy and post-policy for, like, let's say edge ribbing, and then essentially let's see, I mean, are my policies working how I intended to design them, and things like that. So because of that, more work was needed. And this is essentially what I am involved in today. And so I wanted to, you know, tell you, you know, convey you what are the latest and greatest on the protocol. So I don't want to speak to you about what happened in 2016, but what we are doing today at IETF, because as we will see later, I mean, some of the proposals, like I updated like 2 or 3 days ago, and they will go in the IETF meeting next week. And so there is a lot of things going on, and I would like to share them with you, and probably and hopefully interest you in BGP monitoring protocol. So yeah, so that's it. And one thing very true, written in this slide, we go back to the creative minds and things like that. I mean, BMP is a very simple, you know, protocol. It's a TCP session. Essentially, you are wrapping around BGP messages around some other information like timestamp and header and other stuff. But it's incredibly simple. It's one directional kind of protocol, like the monitoring station can never say anything to the router. So it's also kind of safe, let's say, and things like that. And, you know, again, this is super remarkable. You know, when you put a lot of creative minds in one room, come with something that is not complex, it's just amazing. Okay, so traditional BGP monitoring. Let's say that you have, those 5 routers over there, and then you have a root collector, which is this peering router that you see over there. And then they are sending, I don't know, 5 paths, P0 to P4. And then essentially, like, what happens is that, like, you want to analyze the data from the peering router, you know, from this, let's say, root collector. And then the root collector, what it does, it will give you P3, right? And you wonder why P3? I don't know. Who knows? Like, for some reason, it's P3. And so, yeah, this is a little bit the challenge and the information hiding, like just an example of the information hiding that I was, you know, referring before. Like, this is how BGP works essentially. And so essentially, like, what happens with BMP is actually that if I now get P0 to P4 and I have my root collector, and the root collector then is configured with BMP with the, you know, the vantage point, with the, you know, with the, let's say, the analyzer, let's say, then essentially you get all the paths. So now you have an incredible amount of information. You have all the information that you want for your BGP analysis, right? So in very, let's say, if I should make, you know, BMP in one slide, it would be like this one. Like, this is what BMP enables you to do this and to get data in a streamlined fashion. Like, so whatever vantage point you want to look, I mean, it will be always the same. So what are the standardized vantage point in as of 2023? So let's say that this is the typical workflow from, you have a peer, it advertises you something, it's synthesized into a BGP rib, and then you advertise something to, to some other router. Essentially, the 5 vantage points that are standardized are the ones with the red arrows, right? So you have AdRib being pre-policy and post-policy. It's written post and post, sorry. It's a mistake on this slide. Then you have the lock rib, and then you have the AdRib out pre and post-policy, right? So this essentially covers the 5 main vantage point that you have in a router. So it's really like that BMP today can provide you at any stage in the pipeline inside the router, the status of the route. So you could really see, I don't know how, you can validate policies. Now we are coming to the use cases, for example. You can validate your policies, input or output policies. You can see how the BGP attributes do, evolve through the whole pipeline. And of course, you can do a lot of analysis, also security analysis and things like that. The standardized message types are, these 6, 7 over here. And yet again, I mean, it's a very simple protocol, right? So you have the initiation and termination message, like, it's a service message. It's just like, there is a new BMP session, or the BMP session is going away. That's it. It's not very interesting. Then you have the peer up and peer down. So essentially, it's like the peer up is a way to convey the BGP open message to the collector. Why you want the BGP open? Because in the BGP open you have all the BGP capabilities, right? So there is a wealth of information in there. The peer down, it's the notification message, like a notification message if of course the session, the monitored BGP session was shut down cleanly. If it was not shut down cleanly, it would tell you that the session just went kaput, and that's it. And then coming to the real 2 interesting messages, you have a message type 0 and 6, route monitoring and route mirroring. So essentially, like, what is the difference? Both of them, they are meant to convey BGP update messages, right? The only difference between the 2 is that route mirroring would be really a verbatim, like, okay, this BGP message passed on the wire, I'm sending it to you, collector, BMP collector. Whereas the other one, there could be, let's say, imagine that there was a flapping, there was a flapping, like every 100 milliseconds, there was a up, down, up, down, up, down, up, down. Then essentially what happens is that it can make state compression. So you can lose that information of a flapping, right? So depending on the use case that you are really after, like, are you after, oh, okay, I want to see if my network is stable or not, then maybe you want to use route mirroring. For other use cases, maybe you want to do traffic engineering, you don't really care about the stability of the network, and then maybe you want to do route monitoring because you are after the information itself and not the dynamics, right? So it's very interesting, like, also the kind of things that you can do, with this protocol, and, a very simple structure. But let's say, as I was trying to say before, let's say BMP, as it was standardized in 2016, it was appearing pretty much like that, like, 4 legs of a table, but one is a little bit, shorter than the others. And so this is essentially what I am doing. I am, fixing the 4th leg here. And so, now, I mean, now you have to survive through text. Now the figures are finished. Now there is the hard part, right? Okay, so so what is going on? So why I'm saying like that there is still work going on and things like that. So one and probably the most relevant work that is going on now at IETF is adding optional TLVs to BMP messages. So if you remember before, we have the message types and things like that. So like the route monitoring message, which is the main message where you essentially give the BGP updates, essentially like you cannot, you don't have like the possibility to put the TLVs next to the message. So essentially you have a fixed header, you have the BGP update message, and then that's it. Right, so you cannot stick any other information, and it would be very nice to do that. Why? Because maybe you want to annotate this BGP message. So in the update, you have all the NLRIs, so all the prefixes that you are advertising. It would be very nice if you could say, hey, prefix 1, I don't know, it has add path. Prefix 2, it has, I don't know, something else. Or maybe prefix 3 is not active and things like that. So have some sort of annotation. Extract from the router some information that is not necessarily BGP related, but it's state related. So it's in the router. It's related to BGP, but it's not BGP itself, right? So like I was saying before, states. A route is active, is installed, it's not installed, it's backup, and things like that. And so this capability was not there before. This was enough, let's say, meat to say that we want to bump the BMP version from 3 to 4. Like before it was BMP version 3, now it's BMP version 4 if you implement this thing. And to tell you like how active and how debated it has been, really this specific work, like before when I was there, I was updating, this is version 13. You can see there it's version 13. I was making version 14 with some comments that I received right yesterday about it, so it's very dynamic, very evolving. And the second second work, very related to the one before, is that this thing called the enterprise bit in the TLVs. What it means, like it's a very technical wording, the enterprise bit and whatever. But so you imagine that you are standardizing a protocol and you want to develop a new feature in this protocol and things like that. So what you have in the protocol, like the code points and whatever, they have to be standardized. Otherwise, you cannot put them unless you set a bit that is called the enterprise bit, where you say, like, this is a non-standard code point that I'm passing. And this is very important because if you think how things are implemented, I don't know, let's say there is a vendor, I don't know, Cisco, Juniper, Huawei. First thing, what they do is that, like, I am vendor X, I am working with customer Y. Customer Y is interested in something to extract whatever state from the router. I do an implementation for them. And this implementation is non-standard, right? So this is the typical workflow. You never start just from the documents, when you want to add a new feature and things like that. So first you want to prove that there is interest. So everything starts with the customer asking a feature. The feature is implemented, but it's not standard yet. And then you standardize it. So you have to cover that period of time where something is, let's say, experimental. So, and if you don't build that bridge, essentially, you cannot evolve the protocol, right? So what I'm talking about here, it's really strategy, the one before it, and this, how to evolve a protocol, how to make sure that you can add information, how can you make sure that vendors can, work with customers in a good way to develop new features. And that is the only way in which you can make a protocol useful and keep it alive. Path marking TLV is one example of the TLV implementation. Like, it's one kind of TLV that you can put in BMP. And this is very interesting because it's a little bit, I was anticipating this thing before, so it's an extension by which you can put the path status into, a BMP route monitoring message. So essentially you can really say whether a path was active, was standby, was backup, and things like that. So I used, the meat of this work that we are doing here. Actually, it's driven not by me. You can see I'm second author, but by the great Camillo Cardona, which is also my colleague at NTT. Essentially, so you can, with this one, you can really start annotating, the NLRIs and say which one are active or not active, which is very interesting when you have a BGP multipath, for example, right? When you have multiple paths, you really want to know, which ones are active or not, and why you want to do that, because otherwise you would have to simulate everything at the collector, and you never want to do that, right? Because you don't want to say, because if you start doing simulation stuff, then let's say you should really enter into the ins and out of every vendor, like a Cisco router selects paths in a different way than a Arista or a Juniper. Like there are little tiny details that will make one vendor converging a different way. So you don't want to get into this simulation. You want to tell the collector already which paths were selected, not selected, and things like that. This is another super, this is a very new work. And it's probably the one that is more attached to my heart. As you can see, it's again me and Camillo that are proposing this. So if you think the message types that I showed before, so essentially they are to get the whole routing table, let's say out the whole routing table plus the current updates out of a router. So when the session comes up, you get the whole flooding of the routing table, and then all the updates you keep getting, one by one over time and things like that. Fantastic, brilliant. But let's say that at some point we are not interested, or maybe on top of that, we are interested in knowing events. So we want an event-oriented kind of message type. That is something that today in BMP doesn't exist. So let me make just an example. Let's say that you want to see if your policies are working or not working, right? So what you do right now, or what you can do right now, you take ADRI being pre-policy, you take ADRI being post-policy. Essentially, you download this huge list of this wealth of information on the collector, and then you should do a differential analysis, and then you should say, okay, I got 1 million routes from my neighbor. Of these 1 million routes, 999 are accepted. So now let's see which is the route that it was dropped, right? And instead, if you have an event-oriented kind of message type, then with this message type route event logging, essentially you have a message type where you can just say, hey, from ADRI being pre-policy to post-policy, one route was dropped, and the route is this one. So you don't have to do any comparative analysis anymore. Or let's say that you want to say, RPKI, it's a big thing these days. So let's say validation and, of routes and things like that. And so you are very interested in invalid routes, right? So, okay, now imagine that you don't have an event-driven kind of message, then at some point you will receive the information with the other kind of messages that there are some routes that are invalid. Now, you have to go through all the routes and check which ones are invalid or which one transition to the invalid state and things like that. But with an event-driven message, you can immediately get that, not only the amount, but which one are the invalid routes. And so forth. There are, I don't want to say endless cases, but there is a lot of cases for, event-driven messages, which are totally not supported today. And this will make the protocol even, more, let's say, attractive and interesting. And finally, this is the other work that Camilo is driving. It's a BMP young model because we want to be the cool kids. And these days, if you don't have a young model, you are not cool. So we wanted to be cool. And so we have a young model. And so what are the takeaways? So I'm about to release you guys. So we are almost at the end. We are 2 steps from the end. So takeaways. So first of all, like we said, you know, before you needed, let's say, you needed screen scraping and things like that. So BMP is really streamlining, you know, access to the data. So it's uncovering the data and it's streamlining the access to the data. Second thing is that all major router vendors are, you know, implementing it, are supporting it. Of course, this doesn't mean that all that I spoke in here, it's being implemented by all vendors. Let's say that as it happens with standardization, like at different degree, all the vendors do support, you know, more or less features. For sure, what was standardized, you know, in 2016, all the major vendors, they do support it. And now, of course, there is a you know, a lot of, you know, work that we are doing with people that are interested, operators that are interested, like entities interested, another operator that is very active. It's Swisscom. There is also Bell Canada. There is Telefonica as well, all interested in BMP. And so we are all collectively like, you know, working on the vendors. You can think it like the Italian job. One is holding it while the other is kicking it. You know, that's what we are doing with the vendors, like to try to get it implemented. So commerce also in terms of collecting. So the router are you know, exporting this information, and the other part is collection. So there are both commercial and open source implementation, and multiple open source and multiple commercial as well. We use in NTT, we do use it actively, you know, for a number of use cases. And maybe the last thing that I want to say for this slide, like you see over there, is that, you know, so today we spoke about a protocol that is being, you know, standardized and developed at IETF, right? So IETF is, you know, you don't need to show up to a meeting in order to contribute. And the more people that look at things, you know, the more set of eyes, the more minds, brilliant minds are looking at stuff, the more you can catch bugs, you can have ideas and things like that. So for example, if you are interested into BMP, first, use BMP. And second, come at IETF, like on the GROW working group, subscribe to the mailing list. That's all it takes. Read the emails, comment, participate, and you know, you will do a great work for the community. So with that, I'm finished, and I want to also to, you know, take in this kind of work. It's a pro bono work. Like, I mean, you get no money for contributing to IETF. So I'm incredibly happy that a company like NTT is supporting me in this work. And so, like, as a very last thing, I want to say that, you know, we do IP transit and anti-DDoS, and, you know, my colleagues, Graham and Tatiana, they are here. Please stand up, guys. I mean, so if you want to talk about IP transit or anti-DDoS, I mean, you can keep this incredible kind of work going on my side. Thank you. No. Yeah.
Bueno, ¿alguna pregunta por ahí? Paulo.
Ciao, Giorgio.
When you said the young model, just a clarification, I understand that I haven't read the drafts, but I imagine that you have a specific format in which you are exporting the information. I understand this new young model to become cool. You are exporting directly in young format the data, right?
Okay.
So you simplify the collector
No, that's
Would
a
that be
great,
the idea?
that's a great question. So where Yang comes into play? So Yang comes into play that for the configuration part, not for the export part. So the export part is this BMP protocol, but still BMP you have to configure on a router. You have to put commands, BMP, what was that? BMP monitor, whatever, and things like that. So all of that is coded according to a Yang model, right? So it's that is where it fits into the picture. We are not using Yang for the export, and there is no plans to do that.
Was too ambitious, perhaps.
Huh?
Was too ambitious to ask that from vendors.
Yeah.
Okay, so you still need a specific collector for this kind of protocol.
Yes, and also for a reason, because Yang or streaming telemetry in general, let's say streaming telemetry or screaming telemetry, so it's an amazing solution for a lot of stuff like interface counters, QoS, a lot of stuff like that. But BGP has inherently different dynamics than other stuff. So you want the initial flooding and things like that. So having a specific protocol is something that I justify, like for this specific task.
Thank you very much.
Bueno, ¿alguien más? No. ¿Nadie? No. Right. Thank you very much. This is our special gift. Bueno, pues ahora nos toca la asamblea de socios de ESNOG. Así que os recomendamos a los que os queréis quedar que os hagáis socios. Hombre, al que ya es, obviamente no. Bueno, somos una asociación joven, vamos creciendo. Sí, muy importante. El que no se quiera quedar a la asamblea, luego tenemos cervezas. Tenemos la dirección por aquí. Vale. ¿Eh? Sí, hombre, claro que sí. Eso luego ya puedes asistir o no asistir. No estás apuntado para la cena. Pero tal vez me puedan...